Hey everyone, welcome to another Tuesday Tech Tip 45 Drives. Brett Kelly here. We are continuing our little two-parter series in testing out our Ceph Ansible playbooks in a virtual environment. Part one, last week's over there, we learned the basics of Ansible. Just went through the minimum that you will need to know to run playbooks, specifically our playbooks, but really Ansible playbooks in general. This week, we're going to actually apply that. We're going to set up a little virtual environment. I don't particularly care what hypervisor or virtualization program you use, but just kind of to get the scope right, I'm going to plan this in such a way that you can spin up a little one on, like, say, VirtualBox on your laptop. That's kind of the scope. We're not talking a VMware or anything like that. Next, we're going to pull down the playbooks, set up our environment, fill out some variables, do some verification checks, make sure everything's connected, and standard stuff that us at 45 Drives would do when we're setting up a cluster. Then we're actually going to build the cluster, run the playbooks, go onto the dashboard, click around, and, well, let's get into it. All right, welcome to part two of our Ansible learning session. So we've gone over the basics of Ansible, so let's apply them now. We're actually going to build a virtual Ceph cluster. So as you can see in my little table of contents here in the center of the screen, I've broken this into 4 parts because this is going to be a long video, but I figured let's go through every little detail because that'll really help someone go from nothing to a up and running Ceph cluster that they can test out, get comfortable, and everything from there. So again, the main focus of this is to show you how to use our playbooks on not our hardware so you can get a handle for how it all works. So kind of leads me into my point. I want to preface this video and the videos I'm going to create. Usually I prepare beforehand my process, what I'm going to do. So I kind of wrote out the general process of what I plan to do, but I'm going into this blind, because I kind of want to stumble and run into bumps that maybe you, the viewer, is going to run into as well, and we can just work through them, because everyone knows that when you watch those screen cap videos and everything goes perfect, nothing happens like that in the real world. So if we run into bumps, we'll fix them. If we don't, well, great. I guess the process is really nailed out. So with that out of the way, let's dive right into part one. We're going to prepare a virtual environment. So this might be the lengthiest of all of them because you have to do a bit of downloading and installing. So I'm going to start the VirtualBox install, and then I'll get talking here. Next. Usually, especially in Windows, you can just click next. If you want to configure that, go ahead and read ahead, but usually next is fine. I want to state, too, that I'm going to use a Windows machine, and I'm going to use VirtualBox, because I figure that's the like, I don't know, fairest even playing ground to start from. If you have a hypervisor available to you at your work, whether it's VMware or at your home, or a KVM hypervisor, Proxmox, anything like that, go ahead, you can use that as well too. At the core here, we just really need 3 virtual machines, so we're going to do this with the minimum amount of servers. So you do not have to use VirtualBox. You do not even have to use VMs if you want to. You can do this with bare metal servers. Just for those who are virtualizing, we're going to want 3 VMs. We want 2 cores in each, 4 gigs of memory, and about 16 gigabyte of a boot disk. We're going to attach some disks as well. But again, I'm probably going to get redundant and repeat myself a couple times, so just wanted to say that. So now that I have VirtualBox installed, I'm going to get the other long-term download out of the way. Don't worry, we won't screen record this whole process. You're going to want to download CentOS 8 as well. We're going to install CentOS 8, and we're going to install Octopus Ceph, which is the latest release of Ceph. So just go to the CentOS website, grab, you want to go 8. You don't want to do stream, you just want to use 8. So you're going to want to go x86-64. Just grab the closest one to you. In my little corner of the earth, Waterloo actually has the best bandwidth, so we're going to pull from them. You're going to want the minimal ISO, and that's going to start downloading. So I'll be back, guys, when this is finished. Said about technical glitches, you may notice that the background looks different.
I switched machines because I had a big brain moment and was trying to install a bunch of virtual machines on a virtual machine and failed to remember that you cannot do that. So I'm on my home machine. Uh, so we'll continue on here. So I've got CentOS installed and I got VirtualBox installed. So let's make one of the VMs. So bear with me. It's been a bit since I've used VirtualBox. So I'm going to call them VOSD1. I'm going to make another one called 2 and then another one called 3. If you remember from last week's video, I had my Ansible master as a separate host. I'm just going to co-locate everything. All the Ceph services, even the Ansible master, it's just going to be on these 3 VMs. I'm going to stay in guided mode just to keep it simple, like the configuration here. So we're going to pick Linux. I'm going to store it in my default location, and I want to go 4 gigabytes of memory, so 4096 megabytes. Yeah, so I'm going to create a boot disk. Like I said, I'm going to make them with 16 gigs, but you could probably get away with just using 8 gigabytes. And again, this is not any of the storage devices we're going to put into the cluster. It is the boot disk. So we're going to dynamically allocate it so it's only going to use as much space as given. So I'll create 116. Alright, so there's my first VM made, but there are a couple things I have to do to it, particularly networking and storage. I got to give it a couple disks, Ceph cluster, and I want to use a bridged adapter because I want to connect. I want this to get an IP like it's a device on my network. I don't want to use NAT translation, so I'll just hit OK. Actually, no, I should have went up to storage after that. Sorry, where was I? Network. Okay, that's done. Storage. There's one. So I'm going to add another disk. So I'm going to create another disk. So again, this is our storage devices. So we're going to dynamically allocate them so you can make them bigger than they need to be. Just I'll go 100 gigabytes. Just keep in mind, if you do this with a couple 100 gigabyte disks and fill them, it's going to try to fill that much on your computer, so just be aware. But again, dynamically allocated, so if you don't actually put that much data, see how there's only 2 megabytes? That's what it'll look like on. But be aware, if you're actually putting data on this cluster, it will grow to that size. And you know what? I'm going to do 2 of these per OS. Create. Cool. Refresh just for fun. I think we should be good there. No. You click it and then choose. Choose. There we go. Choose. There we go. Okay. Display. I'll give it a bunch of video memory. It shouldn't matter as much because I'm just looking at a terminal. Why not crank it up into the green though? Audio, don't care. Storage, got all my storage. Oh, I need my boot disk, my installer disk. So I'm going to add a optical drive. I'm going to add, let's look at my downloads here, and CentOS 8. So I'm going to choose, okay, perfect. I'm going to remove this one. Okay, I think we're ready to boot. Hit OK. And I'm just going to install one of them now, so we don't have to screen record the process of doing all 3. So let's start our VM. Okay, so yeah, so to get out you have to hit right control. Otherwise your mouse is trapped. So that's what that was telling me. So I guess, yeah, we'll go through the install very quickly here. So you don't need to test this media, just do an install. Okay, great. So it supports, yeah, we don't have to hit right to release our mouse anymore. Right control, sorry. Okay, so our initial login screen, so I'm going to keep it English. Again, configure this for wherever you are in the world. But the defaults are all fine for me. Make this a bit bigger. Scale? No, of course not. So let's go through the system. We're going to install to one of the disks. Done. I'm just going to let it do automatic partitioning. We're going to go to network. We're going to turn on our network adapter. And then there I got an IP. This is on my internal network here. And I can give it a host name. I'm just going to give it a short name. I will give .local just for fun. Yeah, that all looks good. Okay, done. Because I'm going to leave this dynamic because this is fine for me. I don't have enough devices on my network. I'm not afraid of something stealing this IP. But I would really recommend that you go into IPv4 here, you set manual, and you set a manual address. You know what? Don't be lazy. I'll do that right now. Okay, so we'll go manual. You can do DHCP. Just be aware that you might have your IP stolen from you. So I'm on a 2, and let's get up into a range. I know I don't have anything. So 150, 24-bit submask, and 2.1. DNS server 96.2.1. And I'm just going to use 8888. Search domains, I'm good there. So save that. Okay, perfect. That looks fine. Done. We'll go to time and date. We'll select our corner of the earth. I'm picking Glace Bay. That's the closest to Sydney. Cape Breton. My colleague Rob will be very excited to hear that. We'll hit done for network time. And this should be enough. Oh, nope, sorry. Very importantly, so software selection. So we want to only do a minimal install for this. So just select minimal install and select done. Simple. Then begin the installation. I'm going to set a very simple password because I don't want to type it out a million times. Done, done. It told me not to use it because it was too small, but we're in a dev environment. And I'm not going to create a user. I'm just going to be root on this machine for now. So we'll let that go through the install process, and then we'll pick the video back up. Okay, so it's done installing. We'll reboot it. Okay, so this shouldn't take too long at all. Oh, of course, it's booting back into my stupid. Okay, right control, and we want to. I'm just gonna shut it down, and it doesn't support that. Okay, well, guess what? We're doing a hard shutdown. It just because it automatically booted off that installer disk again. So we're gonna go get rid of it. Goodbye. Okay. Now let's start the guy back up. So remember, if you feel like your mouse button is trapped in your VirtualBox machine, then press right control to release it. Once you get into the operating system, you're all right. You don't have to do it anymore. See, I can go back and forth. But I always seem to forget that little tidbit and then freak out because something's not working. Okay, so here's our first system. I don't know if VirtualBox will let me just clone this, so I'm going to, don't mind that. I am doing this at home and my cat walked across the keyboard. Okay, so I'm going to run an update here. When this is finished, I'm going to attempt VirtualBox to just clone the other 3 because I am lazy, and I'd recommend the same for you guys. If not, well, then I'm just going to create 3 more, and we'll pick it up from there. But it's the same process all 3 times. Don't worry, I will screen record the clone process if it doesn't work. I will not screen record the installing of the other 3. Okay, the update's finished. I'm going to install a couple tools I know I'm going to... Well, I don't really need Git. Vim. No, Ceph will do all the other ones. I guess I just really want Vim. Okay, so I'm going to shut this down because I'm going to attempt to clone it. Okay, so clone, perfect. So I'm going to call it VOSD2. MAC address policies. Yeah, new MAC for all network adapters. That seems right to me because I want these to appear like they're on my network. I don't want to keep disk names. I don't want to keep, because I want new stuff. So next. So full clone is an exact copy including all virtual disk files. If you choose link clone, a new machine will be created, but all the virtual disk files will be tied to the virtual. No. So I want to do a full clone. Okay, that looks good. See, so it named everything accordingly. Let's just boot it up to make sure. Because it'll probably copy the network as well. Because I set a static. If I left it DHCP with the new MAC address, it most likely would have given me, it probably would have just worked out of the box. But since we set that IP statically, it probably has the exact same IP. So we're going to go in and change that. And in the meantime, I can clone it again for VOSD3. Oh, again, mind the cat. VOSD3, so we want to generate new MACs, and we don't want to check anything else. And we're going to next, we want a full clone. And off to the races. Oh yeah, see the host name's the same over here too. So we want to fix all that. So we're going to go in, we're going to go to NM2E, so Network Manager Text User Interface. We're going to edit connection, we're going to edit. So, I'm on VOSD2, so I'm going to change that to, of course, there we go. But I can leave all the rest of the information the same. Hit OK, back, and we want to change the host name to osd2.local. So we should be good there. Hit activate. This will give us our new IP. Yeah, looks good. Can we ping the first one? 2.150. No, of course not, because it's not on. Anyway, we'll do a ping test when everything's all done. And you notice the hostname won't change until you exit your session and join again. See, everything's fine. So I'm just going to close this screen for now. Oh, it doesn't let me. Okay, I'll minimize it. I'm going to turn number 3 on. So we're going to do the same process again. We just got to change the network information. So once we get these 3 done, I'm going to create an Etsy host file, like an entry in Etsy host, so we can talk to each server by its name, VOSD 1, 2, and 3, rather than the IP, just because it's a little cleaner to look at. If you have a DNS in your environment, more than welcome to register it in your DNS. But the simplest way is to put it in the host file. Or if you really don't even want to do that, you can just use IPs the whole time. But I like to use names; they're easier. Okay, so I'm in number 3, so we'll do the NM2E again. We're gonna edit. I'm gonna make that go away because I'm tired of looking at it. And this time we're gonna do 152. And I keep forgetting I don't have numlock on. There we go. And everything should be fine there. Let's go back. And we'll set this to 3.local. Okay. Activate connection, turn it off, turn it on. Duplicate IPv6. Probably something to do with the clone. Okay, instead of troubleshooting it, we're going to turn it off because I don't care about IPv6. So we're going to do the same to the other guys too. Alright, everything seems fine there. IPA, that's our new IP. Our host name took effect. Alright, we'll minimize that. I'm going to go back into the other one here, number 2, and I'm just going to turn off IPv6 as well. Again, this is not a requirement. I just don't care to have it on because I'm not using IPv6. Boom, boom. Give her a quick bump. And I'll reboot it. I don't really need to reboot it, but I guess I'm going to. And we'll turn the first one on here. load up. If you hear kind of boops on the microphone, my cat won't leave me alone and keeps swatting my mic, so sorry. But I don't have a door to my office, and she will not go away. Okay, same thing again, I'm just disabling IPv6. We're almost done here. And because it's a VM, I don't care. Why don't you throw it for a reboot? Okay, so 3, 2 should be done. Okay, well they're all done now. So, like I said, let's get some entries into the DNS. I know I'm kind of hopping back from system to system, but we're kind of doing the same thing on each 3 systems, so it doesn't matter too much. So vim etc hosts. So this is pretty simple. We put the IP 2.150. We hit a tab and we say VOSD1. I know I have a longer name there, but it doesn't matter because in this case I'm literally just only ever going to be referring to it by its short name. 152 VOSD3. And we're going to save that. Okay, so everyone's up. So I should be able to ping VOSD1. Great. That's a good sign. Then I should be able to do the same with the second one. Yep. Well, I guess it's just pinging itself. Dirty bird pinging itself. And, alright. Okay, so the 3 can communicate on the network. Great. Some people who are reading ahead might be figuring out right now, they might be screaming at me actually across the screen, go, what about the back-end network? Ceph has 2 networks. In this case, we're only going to use the front-end network because the exercise of setting up a back-end network virtually, like you're not going to see much benefit of the performance, and really what we're trying to do is get you a cluster up. So Ceph can function perfectly fine with just a front-end network. So that's what we're going to do. And once we get into kind of part 2 of all this, of configuring Ansible, I'll show you how that's all set up and everything right now. But we're pretty much at the stage now. I think, yeah, I pinged everyone. I got to do this etc host thing to every server. So I'm going to get back into Uno. Okay, just bear with me, guys, as I type the same thing 3 times. If I was smart, I'd copy the file over, but, well, I don't feel like being very smart today. 68 2.150 VOSD1 192.168.2.151. Don't mind me repeating myself because if I don't, I will give typos. And then it'll all go wrong and I'll be mad and frustrated and we'll never finish this video. Okay, sanity check, pings itself, pings 2, pings 3. Great. And let's hop over to 3 and do the same thing. Vim etc hosts. Insert. I'm using Vim, by the way, for my text editing. It can be a little cryptic on the commands. Like, so you're welcome to use one called Nano as well, which is a little more... Well, let's put it this way. When you get used to Vim, it's the best. If you're not used to Vim, it's annoying. So you don't have to use Vim. But as you can see there, to insert something, you press I, and then you type. To cancel, you hit escape. And then if you want to quit out of it and make your saves, you go :WQ. Sorry for skipping that part. But again, you could use Nano. You would just have to install it like that. Okay, so everyone can communicate. I got to do my sanity check here too. Okay, pings 1, good. Pings 2, good. Pings 3, good. Okay, so our machines are up. They're on the network. We've named them correctly. We've given them the right IPs. Let's move on to configuring Ceph Ansible. All right, let's get close to the Ceph cluster. Let's install Ceph Ansible and configure our variables. So I just kind of wrote out our little process here in my my notepad here. So we're just going to install the 45 drives repo file. Then we'll actually install the Ceph Ansible package. We'll fill out the group vars, the host vars. Remember last week we went through how those work. We're going to fill those out for the environment to build the Ceph cluster. Then we're just going to verify the ping, so make sure everyone can communicate and that the variables look right. And then we're going to move on to deploy the cluster. So let's pull the repo file down. So let's see, repos.d curl.lo 45drives.com ceph rpm ceph underscore 45drives.com. Nope. Autopilot la.repo. Okay, that looks right. Okay, with that there, let's install Ceph Ansible. Oh, too many E's. 45D. Extra. There we go. Okay, so we cannot install the best candidate for the job. Nothing provides Ansible. So, common thing here, we need the EPEL repository. I don't know if I'm saying that right. That's just always what I called it. Okay, with that there, I should be able to satisfy that requirement. So that's just an extra, well, that's it there, extra packages for Ceph. So not in the main, but in a secondary. Okay, so it's going to install Ceph Ansible and then all the dependencies it'll need. And as you can see, there's a mix between our repo, EPEL, the base, AppStream, all kinds of stuff. Okay. Let's go into the directory. So it's user share Ceph Ansible. And here's all our playbooks and variables. So, oh, I forgot an important step here. Our host file. Call it the inventory file, remember. So remember, the inventory file is our list of all the servers organized by their groups, our host organized by their groups, and that way we can tell it which role is which. In this scenario, it's pretty easy. All hosts are doing all roles, but we still need to fill out our inventory file. So we'll call it a host file. And in that, we'll put our first OSDs, VOSD1, VOSD2, VOSD3. Then our second group that we're going to define is the mons. And we need managers. Okay, so this is the core of our cluster. Now obviously there's some other groups, but we'll get to that as we go. Right now we're just going to build the core. So OSDs, mons, managers. With that in place, let's see if we can communicate with everyone. m-ping and all. Remember, so we want to run the ping module across all groups. Now this, and it yells at us because I didn't give it an inventory file. And there we go. It can passwordless SSH into each. So typically if any of these hang or come back failed, either the server's down or it's up and you didn't configure passwordless SSH and it's just kind of hanging there because, well, it's knocking, but no one's letting it in. So until you see 3 green successes here or how many other nodes you're building with, don't continue. Figure out the networking or set up passwordless SSH. Okay, with that good, let's go into our group vars. So we'll go into all.yaml. So remember what we said last week about how group variables work. If we have a file called all.yaml, it'll apply to all the groups and therefore all the hosts. So these are essentially universal settings that we want to set, irregardless of the role that the host could be playing. So most of these are pre-configured, so you don't have to change anything. So I'll just jump right to the important ones. So I'm just going slow so we can see some of these, but remember, like, we've selected a couple sane choices right off the bat, so we can get into this quickly. So first of all, it needs to know a monitor interface. So the monitor interface will be one of the network interfaces of one of the servers that are going to have the monitor role in it. So let me just quit out of this file for a second. That'd be whoever you've defined under the monitor group here. So the mon, sorry. So you'd want it to be the same on all of them. So let's see what that interface is. On me, it's ENP0S3. So not NM2E. Sorry, guys. I want to go in here and I want to define that monitor interface. Did I do that right? Yeah, ENP0S3. Man, my memory sucks at stuff like that. IPs, I'm horrible. Okay, so if that you have a different monitor interface on a different host on 2 and 3, you'll want to define this in a host-specific variable file. But we'll get there. Chances are most of them will be the same because we're building VMs this way. But that's something to keep in mind. So that's the first must-be-defined variable. Everything else here can be left. Okay, here's the next one, public network. So remember what I was saying about front and back end networks, or the public and cluster network, as Ceph calls them here. So we're only going to use the public network. So in my case, I'm on a network block that looks like this. If I was to use a cluster network, or if you configured yourself to use a cluster network, you'd want to uncomment this variable and define that network block. By default, with Ceph, if you don't use a cluster network, it'll just use the public and backend network. It'll just use the public network for both. The OSDs will only communicate on the public network. Okay, so let's move on. So OSD object store, leave that. This next variable is one we've added, hybrid cluster. So the idea here is if you have SSDs and hard drives in your cluster and you want to use both as separate OSDs, you would set this to true. If you want to use hard drives with maybe SSDs as a general wall, you'd leave this false. The point here is do you want separate SSD OSDs or not? Anyway, in our case, these will show up as hard drives, so we're going to leave it false. We can leave all the rest of these basics here, defaults here. This is for Rados Gateway. We'll come back to that. Sorry, the RGW, like the S3 access into the cluster. And yeah, those are the only must define. Oh, geez, no, I forgot the dashboard. The dashboard, the most fun part. So go all the way down to the dashboard block. So you want to set that to true or false. We've picked it to be true. You can change your protocol. All the variables here are pretty self-explanatory. But again, the defaults are just fine. So remember, we changed monitor interface and we changed the public network. And if you have a backend network, you want to change cluster network. So that's it. We can exit out of this file. The next thing we'll want to do is define our host-specific variables. So, let's see, I don't have any host files made. So, for example, we're going to have an SDB and SDC on each node. Now, typically, with 45 drives, we have a playbook called device alias and generate OSD vars. These function only on Storinator storage servers. They do not on just generic hardware. So if you're doing this on anything but a Storinator, don't use those two playbooks. We're going to have to fill these variables out by hand. So remember what we said about host vars last week. We're going to define a vosd1.yaml. I'm just going to leave it blank for now. Oh, there we go. Stupid Vim. I'm going to touch another one here. .yaml and 3. Okay, so now we have to put our files in it. Okay, so let's populate these files now. So again, these are usually generated automatically, but where we're not using physical Storinator or 45 drives products, those scripts won't run, but it's okay because we don't need all the kind of extra stuff that they're doing for us. They're filling some extra variables that we don't need. We only really need to define 2 key variables here. We need to turn off OSD auto discovery. Again, in VMs, actually, this would probably be nice, but whatever, I digress. And LVM volumes. This is the actual, so 2 spaces there. These are our devices, SDB, dev, SDC, I believe. So these are our OSDs. These are the virtual devices we made earlier, the 100 gig virtual hard drives. So SDB and SDC. So because I'm worried about my syntax, let's run a Ansible inventory command and see if it accepted it. Host VOSD1-I host. So what I'm doing here is this will just print out all the variables defined against VOSD1, so I can see if my LVM volumes has took here, because what I'm worried about, YAML is very sensitive about its spacing, and I can't tell if I spaced over enough. So this is a great little verification tool. Okay, well, it didn't error out. That's a great sign, but it's not going to let me scroll, so let's pipe that into less so we can just scroll manually. So we want to take a look for LVM volumes. That's how I know everything's right. Okay, good. I know that it's going to make the 2 OSDs out of there. I can check out OSD discovery too, but I'm pretty confident that that took as well. Yeah, and there it is. Okay, so let's go into host files, take a look. And there we go. So let's just copy that contents over to the other 2 because I don't want to type it out again. And it's the exact same on all of them. So typically, and what someone might be wondering why I'm using individual hostvar files to make the identical variables on all 3 hosts when I have 3 identical hosts. And in this case, we'd probably want to use group vars because then I could just define it across the OSD group. But in reality, once you get a piece of hardware, you don't necessarily put all the disks in the same order. It's good practice to kind of to break out the host files that way. And that's the standard practice we use with our Ansible. That's how they get generated automatically. So I know it seems a little redundant now for after how we learned how Ansible can be so dynamic with its variables, but that's kind of our line of thinking. Yeah, we're good to go with our group vars. Oh, sorry guys. Our group vars, that's where we public address, everything like that. We've defined our OSDs. So let's build the cluster. Okay, with everything ready to go here, we want to build the cluster, but I don't want to use my virtual machine kind of console anymore, because if we do run into errors or anything that I want to kind of troubleshoot away, I can't really scroll in that console window, so that kind of sucks. So I'm going to use putty here and SSH into the box. Log in as root. So I'm just going to minimize that because we don't really need that. I'm going to minimize that. Make this a little bigger, and then I'll make the font a little bigger too. Why not? Change settings. Sorry guys, just a sec. We'll go 16. And I got to turn the bell off because it's going to ding in my ear. Okay, let's get into this. So share Ceph Ansible. So I think we're ready to go. We verified our ping, we verified our variables. Screw it, let's build the cluster. So like I said, we've kind of curated some of these playbooks. So this will build core. Core does the monitors, the managers, the OSDs. This is the core of a Ceph cluster. So we're going to build this, let this finish. I'll let the screen record play all the way through, and then we'll take a look at the cluster when it's done. If it errors out, we'll troubleshoot. We'll figure out what I fat fingered, and we'll go back to the variables and clean it up. So let's build a cluster. So I guess I'll narrate some of what this is doing as it's going, because you're just probably looking, well, we're looking at a stream of tasks right now. But this is the, oh, look, we've got our first failure. It wants a Grafana server group. I forgot about that. So what it's looking for, I think I've got it called metrics. This is what you'll want to do, and this is where it's going to host the all the real-time metrics of your cluster. Your dashboard is going to, the Ceph dashboard uses this to show us all this information. And it should be good there. Let me double check one thing. Oh, of course. Yeah. So metrics is what we've got that called. So makes sense. Where do your metrics go? On your metric server. So as I said before, we're going to define it on, we're going to collocate all the services, so we'll just put it on VOSD for now. So that should be enough to move us past that error of no group files, or sorry, geez, no Grafana server defined. Oh, and as a little aside while we're here, you can go into the root directory and then ansible.log, and it's a playback of everything that you've done. So if you fail and then clear your screen and you want to see your error again, you can go back to root Ansible, or sorry, like the home directory, Ansible log. In our case, yes, so we failed because Grafana server group didn't exist. So I'm going to run this again. And there we go. And now we can see a bunch of green completes. If there was some failed tasks, we would see a failed here on one of them. And you can see the number of OK and changed. But like ideally see 0 failed, 0 failed, 0 failed. Great. Don't worry about skipped. Skips are normal the way Ansible works. Remember, we define every possibility that could happen depending on the variables that you've set. It'll skip some stuff. So again, don't worry about the skips. It's only the faileds that you're worried about. And here's a snapshot of the state of the cluster. So it said it was in health warning, but it was because it was mid building, right? So let's take a look ourselves. So ceph-s is equivalent to Ceph status, and we're looking at a healthy cluster. 3 nodes, 6 OSDs are up. One pool that it made by default, that pool, Ceph OSD pool ls, is for device health metrics, so it just stores that in there. Anyway, so now we're looking at the core of a cluster. Now we can actually do something with it, like install cephfs or RGW. Okay, with the core of the cluster installed, that's great, but it's kind of unusable. I need cephfs or I need RGW for S3 or something. I guess, sorry, it's not unusable. I'm incorrect to make that statement. You can use RBD with the core of a cluster. That's like to use a Rados block device. This is all you need. Anyway, let's make cephfs. That'll be fun. So we'll go Ceph Ansible. No, sorry, Ansible Playbook hosts. So we've already configured all the variables we need to configure for cephfs. By default, this will make us our Ceph data pool and our metadata pool. The way the playbooks are set up, that if you remember I said earlier with the hybrid cluster, if that's true, which means that we're using SSD OSDs and hard drive OSDs, this playbook will be smart enough to put the cephfs metadata on the SSDs, and by default all the data on the hard drives. Now after the fact we can do some mix and matching, but if you have SSD OSDs in the cluster, well, there's a lot of acronyms fast, SSD, OSDs in the cluster, then putting the service files, like RGW service files. Anything that's not directly data related, it doesn't get super large, so it's a pretty good idea to always keep them on flash rather than spinners. Anyway, long story short, we're already all set up to use cephfs. Ooh, as soon as I said that, I realized I was wrong. We need to define another group, another role in our inventory file. We need to define a MDS, a metadata server. And just to spread the load out, let's put it on OSD2. You know what? Let's use two different ones, because ideally you're going to want at least two MDS services running for failover protection. It'll let you do one, but you never want one of anything, right? Okay, cephfs, go. So same idea as the other playbook. It'll run all its roles. It'll do the facts. It'll do defaults. Just gather all the information it needs. It'll run the Ceph infrastructure role. It will open all the firewall ports that it might need. Most of them already are open, but anyway, that's the magic of Ansible. It just does all the stuff for us that you don't even have to quite remember what it's doing or not doing. A joke, of course. We do know what it's doing. Well, this is going, let's kind of layout. So we installed core, which is the OSDs, the mons, and the managers, right? Now we're installing cephfs, which is installing an MDS role. Then let's install the Ceph dashboard. Yeah, I'll leave it at that for now. And we'll plan out the rest of this too. We'll mount cephfs on. I cannot spell, it seems. There we go. I do believe this is nearly done. Yeah, it's just doing its service handling, restarting everything. Okay, I'll give that a second. Okay, there it's done. Well, let's check. Yeah, no fails. And then see, it didn't run any, it barely ran anything on number one because we didn't define it to. So let's do a cephs, ceph-s. And there we go. We've got MDS active, and we have one in standby. And we have 3 pools made now. Ceph, OSD, pool ls. Cool. So before we move on and use cephfs, let's do our last little trick for the day and install the dashboard. So we've been command lining it up this whole time, but Ceph has a dashboard that makes a lot of this stuff easy once it's all deployed. I guess I should talk a little about the kind of metric stack that's getting used. So, Ceph uses Prometheus to store time series data in a Prometheus database. There are other exporters as well too, but I'm talking about kind of what's in the Ceph ecosystem, or has been adopted by the Ceph ecosystem, I guess. So it uses Prometheus and therefore uses Alert Manager as well, two kind of projects by the same developers. Actually, the SoundCloud was the creators of that. Anyway, so Prometheus is the time series database that stores all the metrics. They use Node Exporter, which is an official kind of package that works with Prometheus, and it scrapes all kinds of information from the servers, like CPU memory, disk information, anything good about the hardware and all that. That's what Node Exporter does. And then Ceph itself exports Ceph-specific information through its Prometheus endpoint. Prometheus scrapes both of those, records it in the database, and then we use Grafana and some dashboards that have been made by people in the Ceph team, and that's how we look at all the metrics. So you can look at Grafana as a separate service if you want, I guess browser tab, but they also have it integrated in with the Ceph dashboard. So you can click on a host, take a look at performance data, and it'll show you how the CPU's doing, how much memory you have, how stressed the disks are. Yeah. So, without further ado, this looks like it's finishing up now, and we'll go take a look at the dashboard. So, when it finishes, it gives you a little message here and tells you where you can go to get it. I'm not going to follow that link directly because I don't have my computer here set up to resolve that. So let's go to 2.150:8443, and it doesn't want to let me in because so what's going on there? So we'll go to 2, see if it lets me into 2. No, you got the IP wrong again, man. Anyway, let me get into the dashboard and I'll explain to you what's happening. There we go. Okay, so whoever's the acting manager is hosting the dashboard at that point of time. So if this manager service crashed, failed, restarted, or whatever, it would get picked up by one of the other ones. So when I went to VOSD1 there, so probably when they plopped this message in, it restarted since then, and 2 picked it up. So what happens if you go to one of the other servers, it'll redirect you to the active one. Anyway, that can be changed, or you can put a load balancer in front of it to handle that. But that's why if at first your link doesn't quite succeed here, try again and make sure that the active manager is your dashboard destination. Another little thing you can do, Ceph Manager Services, Ceph MGR Services, will print out whoever the acting dashboard host is at that point in time. Okay, so admin and the password is password, which this password is configurable in that all.yaml file in group vars. So let's log in, admin PA. I don't want to save that. Okay, so this is the dashboard. I won't go through too much detail of it right now, but you're kind of at a glance of what your Ceph cluster looks like. Like I said, with performance. So there's our performance data starting now. Let's look in the last 5 minutes so you get a quick look at everything. Anyway, we're not doing a dashboard demo now. That'll be another video later, but that's our dashboard up. And that's our cluster. Let's look at our pools. There's our cephfs pools. There's our Ceph file system. Cool. But now it's just set up. Let's actually use it. Let's mount it. Let's create a file. So we'll minimize that for now. Actually, you know what? We'll split the screen. So let's mount it, and let's just write some files to it. And so I'm going to use cephfs. Cephfs is a way you can mount it. You can kernel mount this thing, or you can use cephfs. Check out our 45 Drives knowledge base on info on how to do both. I'm going to walk through the cephfs method right now because it's just really easy. So you go cephfs, M, so you point it at a monitor. So in our case, localhost should work. Or it could be the IP of itself, or it can be one of the other monitors. And it needs a mount location. So I want to mount it here. This should fail because this directory doesn't exist yet. Oh, not going to fail, it's just going to hang. Let's try that again. Looks like it's still going to hang. I don't know why. Maybe he doesn't like localhost. Let's try 192.168. No, I know it's a monitor. 150 dot. Sorry, 2.150. There we go. Okay, didn't like localhost, so don't listen to me. You can't use localhost apparently. Anyway, that worked. So we can do df. We can see it mounted there. 188. Big H, so it should be about 200 exactly, right? So we have 200 gigabyte disks in each server, so we have a total of 600 gigabytes. By default, I have 3 replica on these pools. See, replica size 3. So it shows up at 202, right? 600 divided by 3. Cool little hack here. Can I change it? Can't change it in the dashboard, but I can change it here. Ceph OSD pool set size 2. I gotta tell it which pool. I think it goes after. I can never remember the syntax of this off the top of my head. Yeah, that took. Now if I do df again, we should see 300. See, so it's pretty dynamic like that. So say like you're in a critical spot and you're out of data and you're just like, or you're out of room and you're like, man, I need to free some space up. You can just drop it to a size 2. Now, that's more of a cool point. You should expand your data in time rather than just dropping to a size 2. But it illustrates my point. So I'm going to put it back on a 3 for now. And it's pretty cool how it dynamically fixes itself right away. And you can see over the dashboard while it was doing that too, it was adjusting itself. Okay, so it's mounted. Let's make some files. So I'm just going to stream something in here fast, just because I want to show you kind of the reporting and stuff like that. Dev 0, dev null. Nope, that's not going to work. Test.iso. So what I'm doing is I'm streaming zeros through progress viewer into a text file. So I'm not writing anything important. So I want to see some numbers. I want to show you the reporting. Yep, that's about what I'd expect. Speed wise, 3 servers replicated 3 times. 1 gig. No, I'm just making that up. I really don't know what these virtual machines will do performance wise. They're more for illustrative purpose. Like if you really want to get an idea of performance, you should build this with bare metal. But anyway, this just does show you what's going on. So as you can see, the write bytes go up. A little bit of metadata at first, that first write, but it's just one file. Anyway, dashboard. You can see your client throughput here. You can take a look at some more detailed performance here. Let me do a smaller window so you can see the performance ramping up. Anyway, all kinds of cool stuff like that. File systems. So here's the root directory. Oh yeah, that's pretty cool too. Make dir test. Boom. Need to put a quote on it. Say you want no more than 1 file in there. So, oh sorry. Tester. Touch, test 1. Disk quota exceeded. So didn't like, guess that's over my limit. Hit an update. Drop it back to 0. And now I can write my file. Pretty cool. Anyway. Alright, so there's the core of a Ceph cluster deployed on a virtual environment. We've set up cephfs, we've installed the dashboard, we've played around with some quotas, we've moved some files around. This is enough to start your journey into playing with Ceph a little bit. Hope you enjoy.
All right, well, there we have it. We have a virtualized Ceph cluster up. So I hope you enjoyed that little two-part series. As always, I hope you learned something. I hope you enjoyed it. If you have any questions at all, there's a lot of information packed into those two pieces, so reach out. We're here to help. We want to make you guys, whether you're a customer, a home user, someone who's just taking these for a spin, just to learn something, we want to make sure that you feel confident, empowered, and all those synonyms about our solution. So again, if you have any questions, anything at all, reach out. We'd love to help.